Channel Statistics with Mustafa. In today's video, we'll work on a complete practical exercise. Situation 1. We have measurements on height, weight, and width. Width for 10 individuals, and we will analyze them step by step using R. So we'll start preparing the data, for example, either as DataFrame or importing the data using the table from Excel file, CSV file, and then compute the descriptive statistics, visualize the distribution using Boxplot, and then check the normality, evaluate the correlations, and finally perform the hypothesis tests compared to reference values. So let's get started. First, we want to load the appropriate packages, and then we want to create the data frame for each variable, or the values of each variable. For example, height equal to C between parentheses, and put the results here. The same case for weight, and also width equal C between parentheses, and then we copy the results, or the of values of each variable, and paste here. The same case for width. Okay, after checking each variable, height, and also weight, and also width, we can use, for example, create a data frame called data, and use data.frame to combine these three variables. So height, weight, width. So we have successfully create a data frame called data. So data contains three dependent variables, or three continuous variables: height, width, weight, and width, for which refers to the values of measurements on 10 individuals. Then we might want to compute the descriptive statistics for each variable: the mean, median, quartile, and range, using this function. For example, mean, and select our data, which is date also, and select the appropriate variable. So this is the results of mean, of height, of our data, and the same case, or the same way, for the others, which is weight and mean, and select data, and for width. Same case for median, select data and height. These are the results of median, of height, and also median, and select data. Now for weight and median also, and also for data and width. Now, moving now to the other metrics, which is quartiles, using quantile function, and select data, and select, for example, height. This, for example, this is the first quartile, second, and the third. And the fourth one refers to the maximum. This is the third quartile, or and this value refers to the median, and also the second quartile, and these for first quartile. Moving now to the other variables, we can need to avoid redundancy. So moving now to compute a quantile of weight and width. Instead to write, we can copy, no, copy this argument or comment here and select the appropriate variable here for weight and for width. So moving now to the range, which refers to the minimum and the maximum of each variable, data, and select height, and also this results of minimum and this maximum. Range for data and select weight, and also range data and select width. After computing the descriptive statistics, we might want to visualize the results as a box plot of each variable using this function gplot. Plot and select our data, which is data also, and aesthetic graphical x equal to between double quotation marks. For example, we have only one sample here, and y equal to, for example, 8, and then plus geom underscore box plot. We can, for example, write the x-axis as this way, for example, plus xlab between parentheses, between double quotation marks, for example, height. No, sample, for example, sample 1. Very well. Here we can add the results of mean using this comment or argument, stat underscore summary, I think, and fun dot y equal to mean. Geom equal to, but with double quotation marks, point, size equal to 3, shape equal to, for example, 16, 17, or 18, as we want, and the color, for example, equal to black. And then we might want to select or to create compute the correlation and linearity between the relation between each variable, correlation coefficient person, and make scatter plot for each pairwise. So we can only select this function to calculate the correlation coefficient person between each variables. Core function, for example, matrix or correlation equal to, for example, using core function, and then select data. And the method is, for example, equal to person. So the correlation, then we can put here correlation, only correlation, and click to run. So this is the correlation values between each variable, for example, between weight and between pairs, between weight and height. The coefficient correlation person is equal to 0.37, and here equal to 0.69. The same case here and here. So all the value is positive, which indicate that there is a correlation positive between each pairs or pairwise variables. Moving now to create a scatter plot of each between pairwise or between two variables, for example, using the function scatter plot. Scatter plot from package I think tidyverse. I want to load the package tidyverse here. No. Then select the scatterplot function. Tidyverse here, or I think mass. Also HTTP, it's very necessary. and then I want to check it now. Scatter plot from which especially packages, I don't know. Car. Yes, from car package. So scatter plot from car package. I want to add it here. Library car. Very good. So then scatter plot, for example, and use the select, for example, height tilde weight and select data equal to data, and then this is the scatter plot, refers to the relationship between weight and height, and also the same way for any other variables, for example between height and width. This is the results and the regression line here in blue. And then I think we want to move in to the sixth question, which refers to computing the test of comparing between means, which is student. Let's see, after checking the assumptions of normality here, I forgot to check in the normality test here. So we can check the normality using this function from the prosthetics package, Shapiro test wirk. I need to add the data name and then percent and more than percent and Shapiro wirk, and select our dependent variable, which is, for example, in this case of height, only sample here, and select the, for example, the standard or value for height, which is standard value of height, which is 170. No, I think here only this one. This comment is refers to when we want to calculate or compute the t-test, but in a case of Shapiro test, we only should write this argument and check the distribution or also the distribution of data. So in this case, the distribution or the height variable follow a normal distribution because the p-value is greater than 0.05. So the same case for the other variables, height and weight. Also the weight variables follows the normal distribution, and height, I think width. Also width, the p-value of this output indicates that the width variable follows normal distribution. So we can assume this normality or this assumption. Then we can, I think, select the biometric test, which refers to the student test, to check this hypothesis. So first we want to compute or compare the mean of these values of height, whether is the mean is greater than 170 centimeters, and then also we want to check whether the mean of this value of weights is less than 68 kilograms, and finally we want to test whether the mean of width of this sample here is different from 46 centimeters. So it's very easily, we can check it using the t-test, t_test from package statistics, as this comment or following this argument, t_test, and put here the dependent variable, which is height. We have only one sample, and you use the appropriate standard value, which is 170, and also add the argument here, alternative equal to equator, So in this case, the p-value indicates that the mean of height isn't significantly greater than 170. Moving now to check the next hypothesis. So we want to check if whether the mean value of weight is less than 68. We can use this argument here to avoid the redundancy. Here 68 and here put width or weight. Yes, weight. And select less. So these results indicate that the mean of weight isn't statistically less than 68. We will now to check the third assumption or the third hypothesis, which refers to checking whether there is a difference between means of width and the standard value, which refers to 46, using this following. And remove this argument. I think 46 and select width like this one. So also the width value, for example, the p-value indicates that there is a non-significant statute for our t-test. So these results indicate that there is now significantly difference between the mean of width and this standard value. So we can check, or we can draw these results as or add the results of here, for example. Yes, for example, each test here in the box plot figure, following this, for example, argument. We can only, for example, pass this argument and check whether our results are either significant or not significant from the figure. First, we want to name it this following, or this argument or comment. For example, test 1 equal to the t-test for comparing between the mean of weight and this value 170, and test 2 equal to this value, or this comment or argument, and test 3 equal to the t-test for comparing between the mean of weight and the standard value, which refers to 46. And we need only to add here plus, for example, labs and subtitle and write get underscore, I think, get test label, yes, and put here the appropriate test for, in this case, height, test 1, and detailed equal to true. So this is the results of t-test, one sample t-test. This is the results of t-test minus 0.52, and the p-value is not significant, and n refers to number of individuals. The same case for the other variables, width and weight. So I think finally, I think we've seen how to prepare data and also compute descriptive statistics, visualize distribution using Boxplot, check assumptions of normality, and study correlations using core function and select method here person to assess or to compute the correlation person between each variables, between pairways, And also check assumptions of normality here, and then study the correlation, yes, and perform hypothesis test, specialty test, one sample. So finally, if you found this helpful, don't forget to like or subscribe. So see you in the next video on layer statistics with Mustafa, and peace out.